Hello friends, welcome to our learning session about sensitive ground fault detection. In the previous sessions, we are in the fourth session of the third method finding. Now it is our third session about 3I0 stage with measuring the angle between zero sequence voltage and zero sequence current. In the previous session, we discussed about the rotation angle of V reference and how much we should give the settings. We discussed about what the rotation angle is, what the V reference is, and all about in the second session. In the third session, we discussed about the setting values according to our system, how much we should give the value of rotation angle. And forward and reverse direction, we discussed about the direction determination. Now we are discussing furthermore about selecting the direction mode. If we select our direction here as a forward, if we select during the programming, if we select setting, if we select the forward, then if the fault current is in this area here, if the fault current is in these directions, in this area, then the system will trip and pick up because we selected the forward direction for pickups. And if we select the reverse, then when the current is, when the zero sequence current is in this direction, in this area, like this, then our system will pick up. And if we select the non-directional method, or our mode of direction be non-directional, then our system will pick up if the current be in any of these directions, like in this direction, here in this direction, or in this direction, because our system will work as a non-directional. Here we have phi of rotation. That is the value which we give. And the forward section, we here plus or minus, that is the plus or minus of delta phi value which we give. This guy. And now we arrive on the direction determination delay, how much we should give the delay. Why we give the delay? We already discussed before that at initial time of the fault, we have many transients. Here the direction of the current is in reverse because of the system behavior. So we should give some delays so that during this delay, our system should be stabilized, and during this transient condition, we should not have misoperation. Our system should not do any mistake. So we give some time delay. Here in this block, we give 0.1 second as a delay, and the minimum zero sequence voltage for direction determination we gave as 2 volts. Because we need this V0 just only for reference axis. This is not decisive about when the fault should occur. Even though we can limit the initial part mistakes by giving some delays. We give this as 2 volts. And when it passes 2 volts and it passes the time delay, then it will be supplied to the direction determination. It will inform the direction determination block, even though it is initially supplied to this direction because we need some rotation and all. Then all the rotation is done. Now it decides to give output, and also it is supplied to another block for the pickup after passing this time delay and the threshold. And zero sequence compensated value we give according to our system. For example, how much amperes we should give. This depends on your system. You should practically measure in the normal condition the zero sequence current on the system. You should be aware that the actual burden should be connected to the CTs when you want to measure, when you want to know how much the zero sequence component in the normal condition you have. Just you give higher than normal condition, you give the zero sequence component threshold value here, that amount that you want to be tripped when the zero sequence voltage go beyond that value. Then the remaining part is the blocks we have initially given information about each, but here the remaining is blocked by inrush current. If our system mostly have inrush during switching and all, so on that condition we should use that this function should be blocked if there is some inrush on the switching part. And this when there is an inrush, we selected this one as a yes. Then it gives output to AND gate, and this AND is supplied by block 2 is here on the pickup. When there is a pickup and inrush is detected, then it will block, and it will block the operation, and it will show that the operation is blocked by inrush current. Sorry, due to having inrush current, the operation should not be done. And we have some operation delay. This operation delay, it's 0.05 seconds or something. This is according to our system, our desire, how much we should give. And this blocks, actually it blocks the operation. If you have any questions related to these topics which we discussed till 4, you can comment on the videos. Please subscribe our channel and share the video with your friends so that we can provide you more professional, essential, practical, applicable training videos. And on the next session, we will discuss about the direction determination by the admittance of the fault path.